What if the pyramids are 13,000 years old or more? Standing in the shadow of the Great Pyramid, you might wonder why mainstream archaeology insists these monuments are only 4,500 years old. This neat and tidy timeline, which places their construction safely within the bounds of dynastic Egypt, begins to crumble when you look past the textbook explanations. Because these monuments may be survivors of something far older, far more mysterious. They may have stood sentinel through an event so catastrophic it literally reshaped our planet. The Younger Dryas catastrophe, 12,900 years ago. Welcome to Sleep Mysteries, where hidden history meets your bedtime. Tonight, we're going to challenge the official narrative by examining evidence carved into the bedrock itself, erosion patterns that shouldn't exist, precision that defies explanation, and alignments that point to knowledge we supposedly never possessed. You see, there's something about the Sphinx that orthodox archaeology doesn't want to discuss. Deep, vertical weathering carved into the walls of its enclosure. The kind of weathering that only comes from sustained, heavy rainfall. The kind of rainfall that hasn't touched the Giza plateau in over 10,000 years. And there's something about the pyramid stones themselves, cut with a precision that makes modern engineers pause and wonder how such accuracy was even possible with primitive tools. But before we can understand what these monuments truly are, we need to learn something that mainstream archaeology seems to have forgotten. So, if you're drawn to these ancient mysteries, feel free to settle in and stay with me. You won't want to miss where this investigation leads us. Remember to like and subscribe, and let me know where you're watching from. Now let's begin by walking up to the most enigmatic monument on the Giza plateau. Let's stand before the Sphinx and listen to what it's trying to tell us. It speaks in a limestone language older than hieroglyphs, carved not by human hands, but by something far more powerful. Water, lots of it, falling from skies that turned the Sahara into something resembling the Amazon rainforest. But here's the problem with that picture. The last time the Giza Plateau experienced that kind of sustained heavy rainfall was over 10,000 years ago, long before any pharaoh dreamed of carving monuments from stone. Dr. Robert Schoch, a geologist from Boston University, stood in the Sphinx enclosure in the early 1990s and saw something that didn't fit the official narrative. The walls surrounding the Sphinx weren't just weathered. They were scarred. Deep, vertical channels and scalloped indentations ran down the limestone walls like frozen waterfalls. This wasn't the gentle erosion you'd expect from 4,500 years of wind and sand. This was the signature of sustained precipitation, heavy rains that had pounded these walls for centuries. Schoch ran his hands along these grooves, measuring their depth, studying their patterns. What he found changed everything. The erosion was consistent with the kind of weathering you see in regions that experience regular, heavy rainfall over extended periods. The vertical channeling, the rounded profiles, the way the limestone had been carved away layer by layer. It all pointed to one inescapable conclusion. This monument had endured a climate completely different from the arid desert we see today. But there was more. When Schoch examined other limestone monuments from the accepted Pharaonic period, monuments that were supposedly built around the same time as the Sphinx according to Orthodox chronology, he found something remarkable. They showed completely different weathering patterns. The wind and sand erosion you'd expect from thousands of years in a desert climate. Sharp, angular cuts, horizontal striations, the telltale signs of a dry environment slowly wearing away stone. The Sphinx enclosure told a different story entirely. Its walls had been carved by water, not wind, by rain that fell from skies that no pharaoh had ever seen. The limestone had been sculpted by a climate that existed long before the first pyramid was supposedly laid stone upon stone. And if the enclosure walls told the story of ancient rains, then the Sphinx itself had to be older. Much older. Schoch took core samples from the limestone. He studied the mineral deposits left by the water erosion. He calculated the time it would take for such deep channeling to occur under different precipitation levels. Every piece of evidence pointed to the same impossible conclusion. The Sphinx had been carved from the bedrock during a period when the Sahara was green, when monsoon rains swept across North Africa, when the climate was so fundamentally different from today that it might as well have been another planet. The geological evidence was overwhelming. The Sphinx wasn't 4,500 years old. It was at least twice that age, possibly 3 times older. Its witness had the end of the last ice age. It had endured the great melt that raised sea levels around the world. It had survived whatever catastrophe transformed a green, fertile landscape into the desert wasteland we see today. But if the geological evidence was so clear, why did mainstream archaeology refuse to listen? Why did they cling to the conventional timeline in the face of stone testimony that couldn't be argued with or explained away? The answer, they claimed, was simple: style. The Sphinx bore the facial features of Pharaoh Khafra, they argued. It had to have been carved during his reign around 2500 BCE because it looked like him. Case closed. The water erosion could be explained away through a dozen different mechanisms. Wind erosion that somehow looked like water erosion. Unusual weathering patterns caused by ground moisture. Chemical processes that mimicked precipitation damage. But even a casual examination of the Sphinx reveals something that orthodox archaeologists prefer not to discuss. The head is completely out of proportion with the body. It's too small, too narrow, carved from stone that's clearly been reworked. The smooth, fresh-cut appearance of the facial features contrasts sharply with the heavily weathered body. It's as if someone took an ancient monument and gave it a facelift, literally carving a new head from the remains of something much larger. This practice of recarving monuments wasn't unusual in ancient Egypt. Pharaohs regularly appropriated the works of their predecessors, chiseling out old names and replacing them with their own. They carved new faces over old ones, transforming monuments to serve their own propaganda purposes. The evidence for this kind of historical revisionism is found throughout Egypt, from the smallest statues to the grandest temples. So what if the Sphinx had originally been something else entirely? What if Khafra's sculptors had simply recarved an existing monument, taking what was probably a much larger lion's head and reshaping it into a human face? The disproportion between head and body would make perfect sense. The fresh appearance of the facial features compared to the ancient, weathered body would be explained, and the water erosion on the enclosure walls would remain exactly what the geology says it is. Evidence of an age when rains fell on the Giza plateau. The recarving theory isn't speculation. It's based on measurable evidence. Photogrammetric analysis shows clear signs of reworking around the head and neck area. The tool marks are different, the stone texture varies, and the proportions are all wrong for a monument carved as a single piece. Someone, at some point in ancient history, had taken an older sculpture and given it a new identity. But this revelation only deepened the mystery. If the Sphinx was indeed recarved during the Pharaonic period, then the original monument had to be far older than even the radical new geological dating suggested. Old enough to have endured not just the transition from green Sahara to desert, but perhaps old enough to have witnessed whatever catastrophic event caused that transformation in the first place. The limestone walls of the Sphinx enclosure weren't just telling us about ancient rainfall. They were whispering secrets about a world that existed before our current geological epoch began. A world that ended in catastrophe so complete that it left only stone witnesses to tell the tale. So when did these ancient rains fall? When was the Sahara green enough to support the kind of sustained precipitation that could carve such deep channels into limestone walls? The geological record provides a clear answer, and it's one that pushes the origins of the Sphinx far beyond the comfortable boundaries of conventional archaeology. The last great wet period in North Africa occurred during the late Pliocene epoch, roughly 15,000 to 10,000 years ago. This was when the African monsoon system extended much farther north than it does today, bringing seasonal rains to regions that are now bone-dry desert. The Sahara wasn't a barrier then. It was a highway, dotted with lakes and rivers, supporting vast herds of animals and quite possibly human settlements. But this wet epoch came to an abrupt end around 12,900 years ago with the onset of the Younger Dryas period. This wasn't a gradual climate shift. It was a catastrophic snap, a sudden plunge into cooler, drier conditions that transformed the landscape almost overnight. Whatever caused the Younger Dryas, whether it was a comet impact, volcanic winter, or some other global catastrophe, it marked the end of green Sahara and the beginning of the desert world we know today. The timing is crucial. If the Sphinx enclosure walls show evidence of sustained water erosion, and if that erosion could only have occurred during the wet epoch that ended 12,900 years ago, then the monument itself must predate that catastrophic transition. The Sphinx was already ancient when the rains stopped falling. It was already weathered and worn when the desert claimed the plateau. This means the Sphinx witnessed the end of a world. It stood through whatever catastrophe marked the boundary between the Pleistocene and Holocene epochs. It survived the event that triggered the Younger Dryas and watched as the green landscape around it withered and died. By the time the first pharaohs rose to power in Egypt, the Sphinx had already been standing in the desert for over 8,000 years, a monument to a lost age that few even remembered. The geological evidence paints a picture that mainstream archaeology finds deeply uncomfortable. It suggests that sophisticated stone carving and monumental architecture existed in North Africa thousands of years before the rise of dynastic Egypt. It implies that there was a civilization capable of quarrying massive blocks of limestone and shaping them into enduring monuments long before we're supposed to have developed such capabilities. But the Sphinx isn't the only witness to this ancient age. The plateau around it holds other secrets, other monuments that seem to remember a time before time. And when we shift our gaze from the geological evidence to the astronomical alignments built into the Giza complex, the picture becomes even more intriguing. Because the ancient builders, whoever they were, didn't just carve monuments from stone. They carved them from starlight itself, creating alignments that point to specific moments in deep time. Moments that coincide exactly with the geological evidence for the Sphinx's true age. The stars don't lie. They can't be rewritten by conquering pharaohs or reinterpreted by orthodox archaeologists. They follow predictable patterns, cycling through the heavens in ways that can be calculated with mathematical precision for thousands of years into the past. And when we trace those stellar movements backward to the period when the Sphinx was being carved from living rock, we find something remarkable. The pyramids of Giza aren't just aligned with each other. They're aligned with the heavens as they appeared over 12,000 years ago, during the very epoch when the geological evidence suggests the Sphinx was carved from bedrock still wet with ancient rains. Robert Bauval, a construction engineer turned archaeologist, made the connection in the 1990s while studying the layout of the Giza pyramids. The three main pyramids, he noticed, weren't arranged randomly on the plateau. They formed a perfect mirror image of the three stars in Orion's belt, not as those stars appear today, but as they appeared in the night sky thousands of years ago. This discovery, known as the Orion Correlation theory, suggests that the builders of Giza were thinking in astronomical terms when they planned their monuments. They weren't just creating tombs for dead pharaohs. They were building a map of the heavens, frozen in stone for all eternity. But the question that haunted Boval was simple. When exactly were the pyramids aligned with Orion's belt? Using computer programs that can calculate the positions of stars thousands of years into the past, Boval worked backward through time. He watched as Orion's belt slowly shifted its position in the sky, moving through the precession cycle that takes roughly 26,000 years to complete. And at one specific moment in that vast cycle, the correlation was perfect. 10,500 BCE, nearly 13,000 years ago. At that moment in deep time, Orion's belt hung in the southern sky at exactly the same angle as the three pyramids on the Giza plateau. The astronomical alignment was precise, deliberate, unmistakable. The builders had somehow encoded the position of these stars into the very layout of their monuments. But 10,500 BCE presents a problem for conventional archaeology. That date falls squarely in the middle of the last ice age, thousands of years before the rise of agriculture, let alone the complex civilization needed to quarry, transport, and precisely position the massive stone blocks that make up the pyramids. According to orthodox timelines, humans at that point were still hunter-gatherers, struggling to survive in a world locked in ice. Yet the astronomical evidence is unambiguous. The pyramids mark a moment in time when Orion's belt occupied a specific position in the night sky, a position it hasn't held since and won't hold again for thousands of years to come. If the builders wanted to commemorate that celestial moment, they had to have possessed sophisticated knowledge of astronomy, mathematics, and engineering. They had to have been capable of planning and executing construction projects that rival anything built in the modern world. The Orion Correlation isn't the only astronomical alignment at Giza. The pyramids are oriented to the cardinal directions with an accuracy that exceeds many modern buildings. The descending passage in the Great Pyramid points directly at the North Celestial Pole as it appeared in 2500 BCE, while the ascending passages align with specific stars at specific moments in time. The entire complex is a three-dimensional star map, encoding astronomical knowledge that supposedly didn't exist when it was built. But perhaps most intriguingly, the astronomical alignments seem to point to two different time periods. The layout of the pyramids corresponds to 10,500 BCE, while some of the internal passages align with stellar positions from around 2,500 BCE. It's as if the monuments were planned during one epoch, but completed or modified during another, spanning thousands of years of construction and renovation. This dual dating system matches perfectly with the geological evidence from the Sphinx, an original construction phase during the wet epoch over 12,000 years ago, followed by renovation and completion during the Pharaonic period. The monuments we see today are palimpsests, ancient texts that have been overwritten but still bear traces of their original message. The stars remember what the textbooks have forgotten. They preserve the true chronology of Giza in their eternal dance across the heavens, marking moments in deep time when unknown builders looked up at the night sky and decided to mirror its patterns in stone. And those patterns point consistently to the same impossible conclusion. The Giza complex is far older than we've been taught to believe. But if the surface monuments encode secrets of deep time, what lies beneath them might be even more revealing. Because recent investigations have suggested that the Giza Plateau hides chambers and passages that have never been officially explored, spaces that might contain records of the civilization that first carved monuments from the living rock. The whispers began decades ago with a sleeping prophet named Edgar Cayce. In trance states that seemed to transport him across both space and time, Cayce spoke of hidden chambers beneath the Giza Plateau, chambers that contained records from a lost civilization, technological knowledge preserved in crystal and stone, waiting for the day when humanity would be ready to reclaim its forgotten heritage. Mainstream archaeology dismissed Cayce's revelations as fantasy, the product of an overactive imagination rather than genuine psychic insight. But as ground-penetrating radar and seismic surveys began mapping the subsurface of Giza, something remarkable emerged. The plateau was honeycombed with voids, chambers, and passages that didn't appear on any official map. There was something down there, hidden beneath tons of limestone and sand. The most intriguing of these discoveries came in the 1990s when researchers using electromagnetic sounding equipment detected a large rectangular chamber directly beneath the right paw of the Sphinx. The void was substantial, roughly the size of a small building, and it appeared to be artificial rather than a natural cave or fissure. Whatever was down there had been deliberately excavated and sealed. Other surveys revealed additional anomalies, passages leading away from the known chambers in the Great Pyramid, voids beneath the plateau that suggested a network of underground tunnels connecting the various monuments, electromagnetic signatures that hinted at metallic objects or technological artifacts buried in the bedrock. The Giza complex wasn't just what appeared above ground. It extended deep into the earth, a three-dimensional puzzle with most of its pieces still hidden from view. But perhaps the most tantalizing discovery came from the internal structure of the Sphinx itself. Ground-penetrating radar revealed that the monument wasn't solid limestone. It contained internal chambers, hollow spaces that had been carved into the bedrock during the original construction. These weren't natural voids created by weathering or erosion. They were deliberate architectural features, rooms or passages that had been sealed and forgotten for millennia. The implications were staggering. If the Sphinx contained hidden chambers, and if those chambers dated to the original construction over 12,000 years ago, they might preserve artifacts or records from the lost civilization that first shaped the Giza Plateau. They might contain technological knowledge, astronomical calculations, or historical records that could revolutionize our understanding of human development. But accessing these chambers has proven nearly impossible. The Egyptian authorities, under pressure from orthodox archaeologists, have restricted exploration of the subsurface areas. Official excavations have been limited to small, carefully controlled investigations that have revealed tantalizing hints but no definitive answers. The secrets beneath Giza remain locked away, protected by layers of bureaucracy as impenetrable as the limestone itself. Yet the evidence for hidden chambers continues to mount. In 2017, researchers using cosmic ray imaging discovered a large void within the Great Pyramid itself, a chamber that had been sealed since construction and never accessed by modern explorers. The void was substantial, comparable in size to the Grand Gallery, and its purpose remains completely unknown. It's a room that has been waiting in darkness for over 4,000 years, possibly much longer, holding secrets that could reshape our understanding of the monument's true purpose. The pattern is consistent across the entire Giza complex. Surface monuments that encode astronomical knowledge from deep time, geological evidence that points to construction during the last ice age, and subsurface chambers that remain sealed and unexplored. It's as if the entire plateau is a vast library, a repository of knowledge from a lost age, with most of its contents still unread. Casey's prophecies spoke of a hall of records, a chamber containing the technological and spiritual knowledge of Atlantis, sealed beneath the Sphinx until the time was right for its rediscovery. While mainstream science dismisses such claims, the mounting evidence for hidden chambers beneath Giza suggests that the sleeping prophet might have been closer to the truth than anyone wanted to admit. The subsurface mysteries of Giza remain largely unsolved, protected by official policies that limit exploration and independent research. But the evidence that has emerged points to a complex that extends far beyond what meets the eye, a three-dimensional archive that might contain the key to understanding who built these monuments and why they encoded such sophisticated astronomical knowledge into their design. But even without access to the hidden chambers, the monuments themselves tell a remarkable story. A story written not just in astronomical alignments and geological evidence, but in the precision of their construction, the impossible accuracy of their stone cutting, and the engineering solutions that still baffle modern architects and builders. The blocks themselves whisper secrets that orthodox archaeology pretends not to hear. When you stand close enough to touch the limestone surface of the Great Pyramid's remaining casing stones, when you run your palm across what should be rough-hewn ancient masonry, you encounter something that stops you cold. The surface is glass smooth, not metaphorically smooth, not relatively smooth for ancient work, literally, measurably, impossibly smooth. These aren't the rough blocks you'd expect from Bronze Age quarrymen working with copper chisels and stone hammers. These are surfaces that have been finished to tolerances that would challenge modern machine shops. The remaining casing stones on the north face of the Great Pyramid show tool mark so fine, so precise, that they look like they were cut yesterday by industrial equipment rather than 4,500 years ago by primitive tools. Sir Flinders Petrie, the father of modern Egyptology, was the first to measure these surfaces with scientific precision in the 1880s. What he found disturbed him so deeply that he spent years double-checking his measurements, convinced that his instruments were somehow at fault. The casing stones weren't just smooth, they were flat to within fractions of an inch across surfaces that measured dozens of feet. The joints between blocks were so tight that a knife blade couldn't be inserted between them. The angles were cut so precisely that the entire pyramid face maintained a perfect slope across hundreds of thousands of individual stones. Petrie's measurements revealed something that shouldn't have been possible with the technology supposedly available to the ancient Egyptians. The casing stones had been finished to what engineers call optical flat tolerances. These were surfaces so perfectly level that they could be used as precision measuring instruments in a modern workshop. The deviation across a 20-foot section was less than the thickness of a human hair. This wasn't craftsmanship. This was machine precision applied to massive blocks of limestone. But how do you achieve optical flatness on stones that weigh several tons each? How do you maintain that precision across thousands of individual blocks that must fit together with microscopic tolerances? Modern stone-cutting operations use diamond-tipped saws, laser levels, and computer-controlled machinery to achieve such accuracy. The ancient Egyptians supposedly had copper tools and rope. The mystery deepens when you examine the tool marks themselves. Under magnification, the surface of the casing stones shows parallel striations so regular, so evenly spaced, that they look like they were made by a machine feed mechanism. These aren't the irregular marks you'd expect from hand tools wielded by human workers. They're the signature of mechanical cutting, of some device that moved across the stone's surface with clockwork precision. Christopher Dunn, a precision machinist who has studied the Giza monuments for decades, analyzed these tool marks with the eye of someone who understands industrial manufacturing. What he found challenged every assumption about ancient construction techniques. The striations were too regular, too consistent, too perfect to have been made by hand tools. They showed evidence of feed rates and cutting speeds that implied mechanical rather than manual operation. If the ancient builders possessed machines capable of cutting limestone to optical tolerances, what other technologies did they command? How do you power such equipment? How do you design and build precision machinery without metallurgy, without electricity, without the industrial base that modern manufacturing requires? Orthodox archaeology has no answers for these questions. The standard explanation is that the ancient Egyptians were simply better craftsmen than we give them credit for. They achieved these impossible tolerances through patience, skill, and endless hours of hand-finishing work. But this explanation crumbles under examination. No amount of human skill can produce machine-level precision across thousands of individual stones. No craftsman, however talented, can maintain optical flatness over surfaces measured in acres. The remaining casing stones tell a story that textbooks prefer to ignore. They speak of technologies that shouldn't have existed, of capabilities that don't fit the neat progression from primitive to advanced that defines our understanding of human development. They suggest that whoever built the Great Pyramid possessed tools and techniques that we're only beginning to rediscover in the modern era. But the surface perfection is just the beginning. When you move beyond the casing stones to examine the massive core blocks that form the pyramid's internal structure, the mystery becomes even more profound. Because these aren't decorative facade elements where appearance might justify extraordinary effort. These are structural components hidden inside the monument where no one would ever see them. Yet they too show evidence of precision that defies explanation. The core blocks of the Great Pyramid aren't the crude, roughly shaped stones that conventional archaeology describes. They're precisely cut rectangular solids, fitted together with joints so tight that mortar becomes almost unnecessary. Each block has been shaped to exact dimensions, with surfaces that meet at perfect right angles and edges that align with mathematical precision. This level of accuracy isn't just impressive. It's functionally necessary for the pyramid's survival. Engineers who have studied the Great Pyramid's construction understand something that archaeologists often miss. The precision isn't decorative, it's structural. The monument's ability to withstand earthquakes, thermal expansion, and the settling of its massive foundation depends on the exact fit of every single block. A tolerance of even a few degrees or inches, multiplied across hundreds of thousands of stones, would create stress points that could bring down the entire structure. The thermal expansion alone should have destroyed the pyramid millennia ago. Over thousands of years, these thermal cycles should have created cracks, separations, and structural failures throughout the monument. Yet, the Great Pyramid remains remarkably intact, its core structure virtually unchanged from the day it was completed. The reason lies in the precision of the construction. Each block was cut to tolerances so exact that the thermal expansion of one stone is perfectly matched by its neighbors. The joints compress and expand as a unit, distributing stress evenly throughout the structure. Christopher Dunn's analysis of the core blocks revealed something even more remarkable. The stones weren't just cut to precise external dimensions. They showed evidence of internal stress relief, techniques used in modern manufacturing to prevent warping and cracking in large metal castings. Somehow, The ancient builders had understood principles of materials engineering that weren't officially rediscovered until the Industrial Revolution. The precision extends to the microscopic level. When core blocks are examined under magnification, their surfaces show the same regular striations as the casing stones. Even hidden structural elements, buried deep inside the pyramid where no human eye would ever see them, were finished to machine tolerances. But perhaps most remarkably, the precision is three-dimensional. The blocks aren't just flat on their visible surfaces. They're perfectly rectangular solids, with all faces cut to exact dimensions and all angles maintained at precisely 90 degrees. Each block had to be shaped as a perfect geometric form before it could be fitted into its designated position. Every stone had to be measured, checked, and verified before installation. The builders needed standards of measurement accurate to fractions of inches, methods of checking angles to fractions of degrees, and systems for ensuring that each block met specifications before it was lifted into place. Modern construction projects that require similar precision rely on laser measuring devices, computer-controlled cutting equipment, and elaborate quality assurance protocols. The ancient builders achieved the same results with technologies that officially didn't exist. They demonstrate understanding of materials science, structural engineering, and precision manufacturing that places the builders far ahead of their supposed position on the timeline of human development. These aren't the work of Bronze Age craftsmen working with primitive tools. They're the products of an advanced technological civilization that possessed knowledge we're still struggling to understand. Yet conventional archaeology continues to insist that the pyramid was built by workers using copper chisels, wooden levers, and rope. The evidence carved into every stone tells a different story. It speaks of machines and precision, of technologies and techniques that shouldn't have existed when the monument was supposedly constructed. But the precision of individual blocks is only part of the mystery. When you step back and examine the pyramid's overall orientation, when you measure its alignment with the cardinal directions and its relationship to the rotation of the Earth itself, you encounter something even more impossible. You discover that the ancient builders didn't just cut stones with machine precision. They positioned their entire monument with an accuracy that rivals modern satellite navigation systems. The Great Pyramid sits on the Giza Plateau, with its faces aligned almost perfectly to the cardinal directions. Not approximately aligned, not roughly oriented toward north, south, east, and west, but precisely positioned with an accuracy that astounds modern surveyors. The deviation from true north is less than 3/60ths of a degree, an error so small that it falls within the margin of measurement uncertainty. To put this precision in perspective, consider what it means to achieve such accuracy without modern instruments. The builders had to determine true north to within minutes of arc, a measurement that requires either extremely sophisticated astronomical observations or access to precision surveying equipment. They had to maintain that accuracy while laying out a base that covers over 13 acres and positioning massive stones with absolute precision relative to that orientation. The feat becomes even more remarkable when you consider the practical challenges involved. The pyramid's base isn't a simple square marked out on level ground. It's a complex foundation that had to be leveled, surveyed, and positioned on irregular bedrock. The builders had to establish their cardinal orientation before beginning construction, then maintain that precision through every stage of the building process, checking and rechecking their alignment as the monument rose hundreds of feet into the sky. Modern surveyors, working with GPS systems and laser transits, struggle to achieve comparable accuracy on projects of similar scale. The tools required for such precision surveying supposedly didn't exist in the ancient world. Yet somehow, using methods that remain completely mysterious, the pyramid builders achieved results that challenge our best contemporary efforts. The alignment isn't just impressive from a technical standpoint, it's functionally significant. The precision of the cardinal orientation affects every other measurement in the monument. The internal passages, the chamber alignments, the astronomical sight lines, all depend on the accurate positioning of the entire structure relative to the Earth's rotation. A small error in the base orientation would cascade through every subsequent measurement, throwing off calculations that were clearly crucial to the builder's overall plan. But the cardinal alignment is just the beginning. When you examine the pyramid's relationship to other monuments on the Giza plateau, you discover that the precision extends far beyond individual structures. The entire complex appears to have been laid out according to a master plan that encompasses the arrangement of multiple pyramids, the positioning of the Sphinx, and the location of various subsidiary structures. This isn't random construction. It's systematic site planning on a scale that requires sophisticated surveying and coordination across decades of construction work. The second pyramid, attributed to Khafre, sits in precise relationship to the Great Pyramid, maintaining specific angular and distance relationships that suggest careful advance planning. The third pyramid, supposedly built for Menkaure, completes a triangular arrangement that mirrors the constellation of Orion's belt as it appeared in the ancient sky. These aren't coincidental positions. They're the result of deliberate design decisions that required mapping the entire plateau before construction began. They had to visualize the completed complex before beginning work, create detailed plans that could guide construction over generations, and maintain accuracy standards that wouldn't be compromised by the practical challenges of moving millions of tons of stone. Establishing precise angular relationships between monuments separated by hundreds of yards requires optical instruments capable of measuring angles to minutes of arc. Maintaining consistent elevation references across irregular terrain requires leveling equipment with extraordinary sensitivity. Coordinating construction activities across multiple sites requires communication and management systems that rival modern project organization. Yet the evidence is undeniable. The monuments of Giza demonstrate surveying precision that challenges contemporary capabilities. The implications extend beyond the monuments themselves to questions about the civilization that created them. How do you develop such advanced surveying capabilities without a corresponding advancement in all related technologies? How do you achieve precision engineering without precision manufacturing? How do you coordinate complex construction projects without sophisticated organizational and communication systems? The Great Pyramid's cardinal alignment represents just one aspect of a technological package that seems to have appeared fully developed in the ancient world. There's no evidence of gradual development, no progression from crude early attempts to sophisticated final achievement. The precision appears complete from the beginning, as if the builders imported fully mature technologies from some other context. This pattern challenges fundamental assumptions about technological development and cultural evolution. We expect to see gradual improvement over time, with each generation building on the achievements of their predecessors. The Giza monuments show no such progression. They demonstrate capabilities that seem to have emerged without precedent and disappeared without descendants, leaving only stone witnesses to testify to their former existence. But even the remarkable precision of the cardinal alignment pales in comparison to another aspect of the Great Pyramid's positioning. Because when you examine not just the monument's relationship to the cardinal directions, but its specific location on the Earth's surface, you discover something that suggests the builders possessed knowledge of global geography that shouldn't have existed in the ancient world. The Great Pyramid doesn't just sit randomly on the Giza plateau. It occupies a position that demonstrates sophisticated understanding of the Earth's dimensions and geographic relationships. The monument is located at the exact center of the world's landmass, positioned with mathematical precision at the point where the maximum amount of land and the minimum amount of water meet. This isn't coincidence. It's evidence of global surveying capabilities that challenge everything we think we know about ancient knowledge. To understand the significance of this positioning, you have to think like a modern geographer with access to satellite imagery and computer mapping systems. The Earth's land masses are irregularly distributed, with most of the continents clustered in the northern hemisphere and the southern hemisphere dominated by ocean. Finding the exact center of this distribution requires detailed knowledge of continental outlines, accurate measurement of land areas, and sophisticated mathematical calculations. The Great Pyramid sits at 30 degrees north latitude and 31 degrees east longitude, coordinates that place it at the intersection of the longest line of latitude that crosses the most land and the longest line of longitude that crosses the most land. This position represents the geographic center of the world's land masses, calculated to mathematical precision. The builders somehow determined this location without maps, without satellites, without any of the tools that modern geographers consider essential for such calculations. The precision of this positioning suggests capabilities that extend far beyond local surveying. It implies that the builders possessed detailed knowledge of global geography, including the shapes and positions of continents thousands of miles away. They had to understand the Earth as a sphere, calculate the distribution of land masses across its surface, and identify the optimal position for their monument based on worldwide geographic considerations. This level of global awareness shouldn't have been possible in the ancient world. The builders would have needed accurate maps of Africa, Europe, Asia, and possibly the Americas. They would have required methods of long-distance surveying and navigation that could establish precise coordinates across intercontinental distances. They would have needed mathematical techniques for calculating optimal positions based on complex geographic variables. Yet the evidence is undeniable. The Great Pyramid occupies the mathematically optimal position for a monument intended to mark the center of the world's inhabited regions. Its coordinates represent a solution to a geographic optimization problem that requires global knowledge and sophisticated computational capabilities. The builders didn't just understand their local environment, they understood the entire planet. The implications are staggering. If the ancient builders possessed global geographic knowledge, how did they acquire it? Did they have access to worldwide exploration and mapping capabilities? Did they inherit information from even earlier civilizations that had surveyed the entire planet? Or did they possess technologies for remote sensing and geographic analysis that we haven't yet identified in the archaeological record? The global positioning of the Great Pyramid suggests that its builders were part of a civilization with worldwide reach and sophisticated scientific capabilities. They weren't isolated Bronze Age communities working with local resources and limited knowledge. They were members of an advanced culture with global awareness and technological capabilities that challenge our understanding of ancient human development. This revelation transforms our perception of the monument's purpose and significance. The Great Pyramid wasn't just a local construction project or even a regional demonstration of power and skill. It was a global landmark, positioned with mathematical precision to mark a specific point of geographic significance. The builders were thinking on a planetary scale, creating a monument that could serve as a reference point for worldwide navigation and geographic calculation. The precision of this global positioning matches the precision of the monument's construction and orientation. Every aspect of the Great Pyramid demonstrates the same impossible accuracy, the same evidence of capabilities that shouldn't have existed in the ancient world. From the micro-level precision of individual stone surfaces to the macro-level accuracy of global positioning, the monument preserves evidence of technologies and knowledge that challenge everything we think we know about the past. But perhaps most intriguingly, the global positioning suggests that the builders possessed not just advanced knowledge, but advanced communication and coordination capabilities. How do you survey an entire planet and calculate optimal positioning without systems for sharing information across continental distances? How do you coordinate the construction of a precisely positioned monument without communication technologies that could maintain contact with far-flung exploration and mapping teams? The Great Pyramid's global positioning implies the existence of a worldwide civilization with technological capabilities that we're only beginning to understand. Its builders weren't just skilled craftsmen or even advanced engineers. They were members of a culture with planetary awareness and global reach, operating with technologies and organizational systems that remain mysterious even today. Yet conventional archaeology continues to insist that the pyramid was built by a local Bronze Age civilization with primitive tools and limited geographic knowledge. The evidence preserved in the monument's precise positioning tells a different story. It speaks of global surveying, worldwide coordination, and technological sophistication that places the builders far ahead of their supposed position in the timeline of human development. The stones don't just remember local weather patterns or astronomical alignments. They preserve evidence of global awareness and planetary-scale engineering that challenges our most fundamental assumptions about the ancient world. They suggest that our ancestors possessed knowledge and capabilities that we've barely begun to rediscover, technologies that could survey continents and position monuments with precision that rivals modern satellite systems. But even these remarkable achievements in precision construction and global positioning pale in comparison to the most challenging aspect of the Great Pyramid's construction. Because when you examine the massive stone blocks that form the monument's core structure, when you calculate the weights involved and consider the logistics of moving such enormous pieces, you encounter problems that have never been satisfactorily solved by conventional archaeology. The weight problem begins with numbers that seem almost abstract until you try to visualize them in practical terms. The Great Pyramid contains approximately 2.3 million individual stone blocks with an average weight of 2.5 tons each. But averages can be misleading. While many of the upper courses consist of relatively manageable limestone blocks weighing 1 to 3 tons, the foundation courses and internal stones that weigh significantly structural elements include more. The largest blocks in the Great Pyramid weigh between 15 and 80 tons each. To put this in perspective, a 15-ton block weighs as much as 10 automobiles. An 80-ton block weighs as much as 50 cars or 16 elephants. These aren't pieces of stone that can be moved by human muscle power alone, regardless of how many workers you assign to the task. They require mechanical advantage, sophisticated lifting equipment, and transportation systems that can handle enormous loads without crushing the workers beneath them. Conventional archaeology explains the movement of these massive blocks through ramp systems and lever arrangements that supposedly allowed large crews of workers to drag stones up inclined planes to their final positions. The theory sounds plausible until you examine the practical requirements and discover that the proposed solutions create problems larger than the ones they're meant to solve. Consider the basic physics involved. To drag an 80-ton block up a ramp requires overcoming not just the weight of the stone, but the friction between the block and the ramp's surface, plus the additional force needed to overcome the gravitational component acting down the slope. Even with wooden rollers and lubricants, the force required would be enormous. Estimates suggest that moving a single 80-ton block would require between 2,000 and 3,000 workers pulling in perfect coordination. But coordinating 3,000 workers to pull a single stone presents logistical nightmares that make the physics problems seem simple. How do you arrange 3,000 people around a single block so that they can all contribute effectively to the pulling effort? How do you synchronize their movements so that they're all pulling at exactly the same moment with exactly the same force? How do you provide rope strong enough to transmit the combined pulling power of 3,000 workers without snapping under the load? The rope problem alone is nearly insurmountable with ancient materials. Hemp and other natural fibers have limited tensile strength. To handle the forces involved in moving 80-ton blocks, you would need rope with a combined breaking strength measured in hundreds of tons. This would require either single cables impossibly thick or complex arrangements of multiple smaller ropes that could distribute the load without tangling or creating uneven force distribution. Even if you could solve the rope and coordination problems, the ramp itself becomes a construction project that dwarfs the pyramid. To move 80-ton blocks from ground level to positions 400 feet above the base would require ramps with very gentle slopes to keep the pulling forces within manageable limits. A practical ramp slope for such heavy loads would be no steeper than about 8 degrees, which means that a ramp reaching the pyramid's summit would need to be nearly 3,000 feet long. A ramp 3,000 feet long, wide enough for teams of thousands of workers, and strong enough to support 80-ton loads would require more stone than the pyramid itself. You would essentially need to build a second pyramid just to serve as a construction ramp for the first one. And when construction was complete, this massive ramp would need to be dismantled and its material removed, leaving no trace in the archaeological record. The ramp theory also fails to address the precision requirements of block placement. Moving an 80-ton stone up a ramp is difficult enough, but positioning it with millimeter accuracy once it reaches its destination is another challenge entirely. These massive blocks had to be lowered into place with precise alignment, fitted against neighboring stones with joints measured in fractions of inches. This level of precision placement requires lifting and positioning equipment far more sophisticated than simple ramps and levers. Alternative theories have proposed spiral ramps built around the pyramid's exterior, or internal ramp systems incorporated into the structure itself. But these solutions create their own problems. External spiral ramps would interfere with the precise measurement and alignment of the pyramid faces. Internal ramps would require modification of the monument's internal structure, leaving traces that should be detectable in modern surveys. The weight problem becomes even more acute when you consider the granite blocks used in the internal chambers. These stones, quarried in Aswan over 500 miles south of Giza, weigh up to 70 tons each and had to be transported by boat down the Nile, then moved from the river to the construction site, and finally lifted to their positions inside the pyramid. The logistics involved in this operation challenge every assumption about ancient transportation capabilities. Floating a 70-ton granite block down the Nile requires barges capable of handling enormous loads without sinking or becoming unmanageable in river currents. Ancient Egyptian boats were typically constructed of wood and reeds, materials that would be crushed under such weights. Even if suitable barges could be built, loading and unloading 70-ton stones without modern cranes would require harbor facilities and lifting equipment that should have left traces in the archaeological record. The transportation challenges don't end at the harbor. Moving 70-ton granite blocks from the Nile to the Giza Plateau requires crossing several miles of desert terrain, much of it uphill. The blocks would need to be loaded onto wheeled vehicles or sledges capable of supporting their weight, then hauled by teams of animals or workers across sand and rock surfaces that would bog down or destroy conventional transportation equipment. Once at the construction site, these 70-ton granite blocks had to be lifted to positions inside the pyramid and fitted with the same precision demanded of all the monument's components. The King's Chamber, located near the center of the pyramid about 140 feet above ground level, contains granite blocks that somehow made this entire journey and were positioned with millimeter accuracy in one of the most inaccessible locations in the entire structure. The conventional explanations for these achievements rely on assumptions about ancient capabilities that have never been demonstrated experimentally. No one has successfully moved stones of comparable weight using only the tools and techniques supposedly available to the pyramid builders. No one has constructed ramps capable of handling such loads. No one has demonstrated transportation systems that could move 70-ton granite blocks from Aswan to Giza using Bronze Age technology. The weight problem represents one of the most fundamental challenges to conventional theories about pyramid construction. The numbers simply don't add up. The forces required, the equipment needed, the logistical coordination demanded, all exceed what should have been possible with ancient technology. Yet the stones are there, positioned with impossible precision, testimony to capabilities that remain unexplained. But the granite blocks present more than just a transportation puzzle. When you examine their precise positioning within the pyramid's internal structure, when you consider the engineering requirements for supporting such massive weights in mid-air chambers, you encounter evidence of structural sophistication that challenges our understanding of ancient architectural knowledge. The granite blocks that form the King's Chamber don't just challenge our understanding of ancient transportation. They demonstrate engineering principles that shouldn't have existed in the Bronze Age. These aren't simple rectangular stones stacked like building blocks. They're precisely cut architectural elements, designed to work together as a unified structural system that could support enormous loads while maintaining perfect geometric relationships. Each granite block in the King's Chamber walls was shaped to exact specifications, with surfaces ground to optical flatness and edges cut to perfect right angles. But more remarkably, the blocks were designed with interlocking features that distribute structural loads across the entire wall system. Hidden within the thickness of each stone are carefully calculated stress relief channels, expansion joints, and load-bearing features that demonstrate sophisticated understanding of structural mechanics. The ceiling of the King's Chamber presents an even greater engineering challenge. 9 massive granite beams span the chamber's width, each weighing approximately 25 tons, positioned with such precision that the joints between them are nearly invisible. These beams don't simply rest on the chamber walls. They're integrated into a complex structural system that includes 5 separate relieving chambers stacked above the main ceiling, each designed to redirect the enormous weight of the pyramid's upper courses away from the chamber below. This multi-layered stress relief system represents one of the most sophisticated examples of structural engineering in the ancient world. The builders understood that a simple flat ceiling couldn't support the millions of tons of stone pressing down from above. They designed a graduated load distribution system that channels weight through a series of corbelled arches and relieving chambers, each layer carrying a portion of the total load. The precision required for this system goes far beyond impressive craftsmanship. Each relieving chamber had to be positioned with mathematical accuracy relative to the others. The corbelling angles had to be calculated to distribute loads evenly across the supporting walls. The expansion joints had to be sized to accommodate thermal movement without compromising structural integrity. This level of engineering requires not just advanced construction techniques, but sophisticated understanding of materials science and structural analysis. Modern structural engineers who have studied the King's Chamber relieving system recognize it as a masterpiece of load distribution design. The principles involved weren't officially rediscovered until the development of modern concrete and steel construction techniques. Yet somehow, working with primitive tools and supposedly limited mathematical knowledge, the ancient builders created a structural system that has successfully supported enormous loads for over 4 millennia. The construction sequence for these relieving chambers presents logistical challenges that compound the already impossible transportation problems. Each layer had to be built in perfect alignment with the layers below, requiring precise surveying and positioning at heights that made access extremely difficult. The granite beams for each level had to be lifted into position and aligned with tolerances measured in fractions of inches, all while working in confined spaces with limited visibility. The tool's marks on the granite beams tell their own story of impossible precision. Under magnification, the surfaces show the same regular striations found on the pyramid's exterior stones, evidence of mechanical cutting rather than hand tooling. These marks are particularly significant because granite is one of the hardest stones used in construction, requiring diamond-tipped tools or advanced abrasive techniques to achieve smooth finishes. Working granite to the precision demonstrated in the King's Chamber requires not just hard-cutting tools, but methods of holding and positioning the workpieces that can maintain accuracy while applying enormous cutting forces. Modern granite fabrication relies on computer-controlled machinery, diamond cutting wheels, and precision fixturing systems. Yet ancient builders achieved comparable results with technologies that remain completely mysterious. The relieving chambers also preserve evidence of construction techniques that challenge conventional theories about ancient building methods. The granite blocks show no evidence of having been dragged across abrasive surfaces or lifted with ropes that would leave characteristic wear marks. Instead, they appear to have been positioned with methods that left the stone surfaces unmarked, suggesting lifting and handling techniques far more sophisticated than the crude systems proposed by orthodox archaeology. But perhaps most remarkably, the entire relieving chamber system had to be planned and executed as part of the pyramid's original design. This wasn't a modification or repair added after construction problems became apparent. The chambers were integral to the structural concept from the beginning, requiring that the builders understand the load requirements and stress distributions before laying the first foundation stone. This level of advanced planning implies capabilities that extend far beyond individual construction projects. The builders had to possess theoretical understanding of structural mechanics, mathematical tools for calculating load distributions, and design methods that could predict the performance of complex architectural systems. They were operating not as skilled craftsmen following traditional techniques, but as structural engineers working with advanced analytical methods. The King's Chamber relieving system represents just one example of the sophisticated engineering found throughout the Great Pyramid's internal structure. Every aspect of the monument's design demonstrates the same impossible combination of theoretical knowledge and practical precision, the same evidence of capabilities that shouldn't have existed in the ancient world. Yet conventional archaeology continues to insist that these achievements resulted from trial and error experimentation by Bronze Age builders working with primitive tools. The evidence carved into every stone tells a different story. It speaks engineering of systematic design, of mathematical analysis, of construction techniques that rival modern capabilities. The relieving chambers aren't the work of ancient craftsmen learning through experience. They're the products of a technological civilization that possessed knowledge we're still struggling to understand. The granite blocks of the king's chamber preserve secrets that go far beyond impressive stonework. They demonstrate understanding of structural mechanics, materials science, and precision engineering that places their builders among the most sophisticated civilizations in human history. Yet this advanced knowledge appears without precedent in the archaeological record, as if it emerged fully developed from some unknown source. The mystery deepens when you consider that this level of engineering sophistication appears only in the Great Pyramid and a few other monuments from the same mysterious epoch. Later Egyptian construction, while impressive in its own right, never again achieved the precision and technical sophistication demonstrated at Giza. It's as if the knowledge required for such advanced engineering was available for a brief period, then lost or deliberately hidden. The relieving chambers stand as monuments to capabilities that challenge our understanding of technological development and cultural evolution. They preserve evidence of knowledge that shouldn't have existed, techniques that shouldn't have been possible, and precision that shouldn't have been achievable with ancient tools. They're witnesses to a lost age engineering excellence that modern of civilization is only beginning to appreciate. But the structural sophistication of the king's chamber is only one aspect of the Great Pyramid's internal mysteries. When you examine the narrow passages that connect the chambers, when you trace the perfectly straight shafts that penetrate hundreds of feet through solid stone, you encounter engineering challenges that push the boundaries of impossibility even further. The so-called air shafts of the Great Pyramid represent one of the most puzzling aspects of the monument's internal design. These narrow passages, roughly 8 inches square, extend from the king's and queen's chambers through hundreds of feet of solid stone to emerge at precise points on the pyramid's exterior faces. They maintain perfect straightness and consistent dimensions across their entire length, achievements that would challenge modern drilling and excavation techniques. The northern shaft from the king's chamber runs for approximately 235 feet through the pyramid's core masonry, climbing at a precise angle of 32 degrees and 28 minutes. The southern shaft extends for about 175 feet at an angle of 45 degrees and 14 minutes. Both passages maintain their square cross-section and smooth walls across their entire length, never deviating from their calculated paths, despite passing through hundreds of individual stone blocks. The precision required to create these passages defies conventional explanation. How do you bore a perfectly straight hole through 235 feet of solid stone while maintaining an exact angle and consistent dimensions? Modern tunnel boring requires laser guidance systems, computer-controlled cutting heads, and continuous surveying to maintain accuracy across such distances. The ancient builders achieved comparable precision with methods that remain completely mysterious. The construction challenges become even more daunting when you consider the practical requirements for creating these shafts. Unlike modern tunnel boring that proceeds from one the other, end to the pyramid's air shafts had to be carved as the monument was being built, with workers somehow maintaining perfect alignment while constructing the pyramid around them. This requires three-dimensional coordination that exceeds the capabilities of most contemporary construction projects. Each stone block that the shafts pass through had to be precisely cut before installation to accommodate the passage. The shaft walls had to align perfectly with the corresponding openings in adjacent blocks, creating a continuous tunnel through hundreds of separate stone elements. A single misaligned block would have disrupted the entire shaft, requiring demolition and reconstruction of substantial portions of the pyramid. The surveying requirements for this achievement are staggering. The builders had to establish the exact path of each shaft before beginning construction, then maintain that path with millimeter accuracy as the pyramid rose around them. They needed surveying methods that could project straight lines through three-dimensional space across distances measured in hundreds of feet, all while working in confined spaces with limited visibility. Modern surveying would accomplish this task using laser transits, electronic distance measuring equipment, and computer-assisted calculation systems. The ancient builders achieved the same results with tools that supposedly didn't exist, using methods that remain completely unexplained. The precision of their work exceeds what most contemporary tunneling projects achieve, even with advanced guidance systems. But the air shafts present more than just construction challenges. Their purpose remains one of the Great Pyramid's greatest mysteries. Despite their common name, these passages weren't designed for ventilation. They don't connect directly to the chambers they serve, instead terminating in small openings that were originally sealed with stone blocks. Their true function appears to be far more complex than simple air circulation. Recent investigations have revealed that the shafts are precisely aligned with specific stars as they appeared in the ancient sky. The northern shaft from the king's chamber points toward the star Thuban, which served as the pole star during the pyramid's supposed construction period. The southern shaft aligns with Orion's belt, the constellation that ancient Egyptians associated with Osiris and the afterlife. These stellar alignments suggest that the shafts served astronomical rather than practical purposes. They appear to be carefully calculated sight lines, designed to frame specific stars at specific moments in time. This interpretation transforms the passages from simple ventilation systems into sophisticated astronomical instruments, precisely calibrated to track the movements of celestial bodies. The precision of these astronomical alignments rivals the accuracy of modern observatory equipment. The shafts maintain their target orientations to within fractions of degrees across their entire length, ensuring that the star sightlines remain accurate despite the enormous distances involved. This level of astronomical precision requires not just advanced surveying techniques, but sophisticated understanding of celestial mechanics and stellar movement. The shaft alignments also demonstrate knowledge of precession, the slow wobble of the Earth's axis that causes star positions to shift over thousands of years. The builders had to account for precessional movement when calculating their sightlines, requiring understanding of astronomical cycles that weren't officially recognized until modern times. This knowledge places them among the most sophisticated astronomers in ancient history. But perhaps most remarkably, the shafts appear to encode multiple layers of astronomical information. While their primary alignments point to specific stars, their angles and dimensions also correspond to various solar and lunar cycles. The passages seem to function as three-dimensional astronomical calculators, preserving knowledge about celestial mechanics in their very geometry. The southern shaft from the Queen's chamber presents an additional mystery. Unlike the other passages, this shaft doesn't extend to the pyramid's exterior. Instead, it terminates deep within the monument at a small chamber that was discovered only recently using robotic exploration equipment. The chamber contains what appear to be copper fittings and stone doors with metal handles. artifacts that suggest the shaft system served purposes far more complex than astronomical observation. These artifacts raise profound questions about the pyramid's internal systems. Were the shafts part of some kind of mechanical or technological installation? Did they serve functions that we haven't yet identified? The copper fittings and stone doors suggest that the passages were designed to be sealed and unsealed, perhaps as part of some operational system rather than simple sightlines. The precision of the air shafts extends to details that wouldn't matter for crude ventilation or even basic astronomical observation. The corners are perfectly square, the walls are smooth as glass, and the dimensions remain constant to within millimeters across hundreds of feet. This level of finish suggests that the passages served functions requiring extreme precision, functions that remain mysterious even today. Modern attempts to explain the air shafts through conventional archaeological theories have failed to account for their precision, their astronomical alignments, or their internal artifacts. The passages represent engineering and astronomical achievements that challenge every assumption about ancient capabilities. They preserve evidence of knowledge and techniques that shouldn't have existed, created with precision that rivals modern standards. The air shafts stand as monuments to the sophisticated knowledge possessed by the pyramid's builders. They demonstrate understanding great of astronomy, precision engineering, and three-dimensional construction coordination that places their creators among the most advanced civilizations in human history. Yet this knowledge appears without precedent, as if it emerged fully developed from some unknown source. Like every other aspect of the Great Pyramid, the air shafts challenge our understanding of technological development and ancient capabilities. They preserve evidence of achievements that shouldn't have been possible, created with precision that shouldn't have been attainable, designed with knowledge that shouldn't have existed. They're witnesses to a lost age of scientific and engineering excellence that we're still struggling to understand. But even the remarkable precision of the air shafts and the sophisticated engineering of the relieving chambers don't address the most fundamental question about the Great Pyramid. What was it actually for? Because when you strip away the assumptions about royal tombs and examine the monument's actual characteristics, you discover something that challenges the very foundation of conventional archaeological interpretation. The Great Pyramid has never functioned as a tomb in any recognizable sense. Despite over a century of intensive archaeological investigation, no mummy has ever been found within its chambers. No burial goods, no canopic jars, no hieroglyphic inscriptions identifying a pharaoh or describing funeral rites. The monument is completely devoid of the artifacts and decorations that characterize genuine Egyptian tombs from every historical period. This absence isn't simply the result of ancient tomb robbing. Genuine Egyptian burial sites, even when thoroughly looted, preserve traces of their original function. Broken pottery, scattered jewelry, fragments of mummy wrappings, disturbed burial furniture. The archaeological signature of a tomb is unmistakable, even after thousands of years of interference. The Great Pyramid shows none of these indicators. More significantly, the pyramid's internal design bears no resemblance to known Egyptian burial practices. Royal tombs from the New Kingdom are decorated with elaborate paintings depicting the pharaoh's journey through the underworld. Their chambers are filled with religious texts, magical spells, and detailed instructions for navigating the afterlife. The walls are covered with hieroglyphs identifying the deceased ruler and proclaiming his divine status. The Great Pyramid's chambers are stark, undecorated spaces with no religious artwork, no identifying inscriptions, no evidence of ritual use. They're functional rooms designed for purposes that remain completely mysterious. The king's chamber contains a granite sarcophagus, But this artifact shows no evidence of ever having contained a burial. It lacks the inscriptions, decorations, and structural features that characterize genuine Egyptian sarcophagi. The sarcophagus itself presents its own mysteries. It's cut from a single block of red granite with precision that exceeds modern manufacturing standards. The internal dimensions are calculated to mathematical precision, and the walls are polished to optical flatness. But it lacks a fitted lid, shows no evidence of ever having been sealed, and contains none of the religious symbolism that decorates authentic burial containers. Even more puzzling, the sarcophagus is slightly larger than the passages leading to the king's chamber. It couldn't have been moved into position after the chamber was completed, which means it was installed during construction as an integral part of the monument's design. This suggests that the sarcophagus wasn't intended as a burial container that would be sealed after funeral rites, but as a permanent fixture designed for some ongoing function. The pyramid's internal architecture tells the same story. The passages and chambers aren't designed to be sealed permanently after a burial ceremony. They include features like the granite plug blocks that could be removed and reinstalled, suggesting that the internal spaces were meant to be accessible for repeated use. This is completely inconsistent with Egyptian burial practices, which emphasized permanent sealing to protect the deceased pharaoh's remains. The absence of any religious or funerary purpose becomes even more apparent when you consider the monument's acoustic properties. The king's chamber exhibits remarkable resonant characteristics, with specific frequencies that cause the entire room to vibrate in harmony. The granite walls and ceiling act as a resonating chamber, amplifying and focusing sound waves in ways that suggest deliberate acoustic design. These acoustic properties have no relationship to burial practices but suggest that the chamber was designed for activities involving sound, vibration, or resonance. Some researchers have proposed that the pyramid functioned as a massive acoustic device, perhaps for meditation, healing, or some form of sonic technology that we don't yet understand. The precision of the chamber's dimensions and the carefully calculated proportions all contribute to its acoustic characteristics. The pyramid's internal systems also suggest ongoing operational requirements rather than static burial functions. The air shafts, despite their name, appear to be part of some kind of circulation or processing system. The relieving chambers above the king's chamber create complex airflow patterns that might have served technological rather than structural purposes. The entire internal architecture suggests a monument designed for active use rather than passive commemoration. Recent discoveries have revealed additional chambers and passages within the pyramid that weren't included in the original archaeological surveys. Ground-penetrating radar and cosmic ray imaging have identified voids and structures that suggest the monument's internal complexity far exceeds what's been officially mapped. These hidden spaces imply that the pyramid's true function remains largely unknown, with most of its systems still sealed and unexplored. The electromagnetic properties of the pyramid present another puzzle that has no relationship to burial practices. The monument appears to interact with natural electromagnetic fields in ways that suggest deliberate design rather than accidental characteristics. Some researchers have proposed that the pyramid functioned as a massive energy-focusing device, concentrating and directing electromagnetic forces for purposes that remain mysterious. The geographical positioning of the Great Pyramid also argues against a simple burial function. Its location at the mathematical center of the world's landmasses suggests global rather than local significance. This isn't the kind of positioning you'd expect for a pharaoh's tomb, but it makes perfect sense for a monument intended to serve worldwide purposes. The builders were thinking on a planetary scale, creating a landmark that could function as a reference point for global navigation and geographic calculation. The precision of the pyramid's construction and orientation also exceeds what would be necessary for a burial monument. The impossible accuracy of the stonework, the perfect alignment with cardinal directions, the sophisticated engineering of the internal systems all suggest purposes that required extreme precision. Burial tombs don't need optical flat surfaces or millimeter-accurate positioning. The level of precision built into the Great Pyramid implies functions that demanded mathematical perfection. The monument's relationship to the other structures on the Giza Plateau also argues against individual burial purposes. The three pyramids are precisely positioned relative to each other and to the Sphinx, creating a unified complex that appears to function as a single integrated system. This kind of coordinated site planning suggests that the monuments were designed to work together for some common purpose, rather than serving as separate burial sites for different pharaohs. The absence of any convincing burial evidence, combined with the monument's obvious technological sophistication, points to a function far more complex than a royal tomb. The Great Pyramid appears to have been designed as some kind of operational facility, a monument that required ongoing maintenance and use rather than simple commemoration of a dead ruler. The builders invested enormous resources and demonstrated impossible capabilities to create a monument that preserves no evidence of burial use, but abundant evidence of technological sophistication. They were clearly not building a tomb in any conventional sense. They were creating something that required precision engineering, astronomical alignment, acoustic properties, and electromagnetic characteristics. They were building a machine whose purpose we have yet to understand. The true function of the Great Pyramid remains one of archaeology's greatest mysteries. But the evidence is clear that it wasn't built primarily as a burial site. The monument represents something far more sophisticated and purposeful, a technological achievement that challenges our understanding of ancient capabilities and suggests purposes that we're only beginning to imagine. This revelation transforms our perception of the entire Giza complex. We're not looking at ancient burial grounds, but at the remains of a technological installation created by a civilization with capabilities that we've barely begun to understand. The monuments preserve evidence of knowledge and purposes that remain as mysterious today as they were when the first archaeologists began their investigations over a century ago. But if the Great Pyramid wasn't built as a tomb, and if its construction required technologies that shouldn't have existed in the ancient world, then who were its builders? What kind of civilization possessed the knowledge and capabilities necessary to create such monuments? The answer to this question challenges everything we think we know about human history and the development of technological civilization. The builders of the Great Pyramid, whoever they were, possessed knowledge that spans multiple advanced scientific enough to encode disciplines. They understood mathematics well, complex geometric relationships into their monuments' proportions. They mastered astronomy to the point where they could calculate stellar positions thousands of years in advance and align their structures with mathematical precision. They developed engineering techniques that allowed them to quarry, transport, and position massive stone blocks with accuracy that rivals modern capabilities. But perhaps most remarkably, they possessed metallurgical and manufacturing knowledge that shouldn't have existed in the Bronze Age. The precision of their stonework implies cutting tools harder than they worked. Materials. The tool marks on granite surfaces suggest mechanical rather than manual cutting and electromagnetic properties of their techniques. The acoustic principles of physical monuments indicate understanding that weren't officially discovered until modern times. This technological package didn't develop gradually over centuries of incremental improvement. It appears fully mature in the archaeological record, as if the builders imported complete scientific and engineering knowledge from some other context. There's no evidence of primitive early attempts, no progression from crude experimental constructions to sophisticated final achievements. The capabilities demonstrated at Giza seem to have emerged without precedent and disappeared without descendants. The geological evidence places these builders in a period before the Younger Dryas catastrophe, during the wet epoch when the Sahara was green and the global climate was fundamentally different from today. They lived through whatever event triggered the sudden transition to our current geological period, a catastrophe so severe that it reshaped continents and eliminated entire ecosystems. Yet somehow their monuments survived. The astronomical alignments encoded in the pyramids point to the same pre-catastrophic period, around 10,500 BCE, when the constellations occupied positions they won't hold again for thousands of years. The builders were recording stellar configurations from deep time, preserving astronomical knowledge in stone that could survive any conceivable disaster. They were thinking in terms of geological timescales, creating monuments that could endure for millennia. This suggests a civilization that understood its own vulnerability, that recognized the approaching catastrophe and took deliberate steps to preserve knowledge for future generations. The precision and durability of their constructions weren't just impressive achievements. They were survival strategies, methods of encoding information that could outlast the collapse of their entire technological civilization. The global positioning of the Great Pyramid implies that these builders operated on a worldwide scale. They possessed detailed knowledge of continental geography and could coordinate construction projects across intercontinental distances. This wasn't a local Bronze Age culture working with limited resources. It was a global civilization with technological capabilities that enabled worldwide exploration, mapping, and construction coordination. The sudden disappearance of this advanced knowledge after the Younger Dryas suggests that the catastrophe was more than just a climate change. It was a civilization-ending event that disrupted technological systems, scattered populations, and forced survivors to rebuild from primitive conditions. The monuments at Giza preserve evidence of the technological peak that existed before the collapse, witnesses to capabilities that took thousands of years to redevelop. The implications extend far beyond archaeology to fundamental questions about human development and technological progress. If an advanced civilization existed over 12,000 years ago, what happened to their descendants? How much knowledge was lost in the catastrophic transition to our current epoch? Are we rediscovering technologies that were once common knowledge, or developing entirely new approaches to problems our predecessors had already solved? The builders of Giza challenge our assumptions about linear progress and technological development. They demonstrate that advanced knowledge can emerge, flourish, and disappear, leaving only stone witnesses to testify to former greatness. They suggest that human history is far more complex and cyclical than we've been taught to believe, but perhaps most significantly, they prove that sophisticated civilization can survive catastrophic global changes if sufficient preparation and foresight are applied. The monuments they left behind weren't just impressive constructions. They were messages sent across thousands of years, proof that intelligence and determination can create works that outlast any conceivable disaster. The identity of these builders remains mysterious, but their achievements stand as permanent testimony to human potential. They faced a global catastrophe that ended their world, yet managed to preserve evidence of their capabilities in monuments so durable and precisely constructed that they continue to challenge our understanding thousands of years later. They were our predecessors in more than just chronology. They were examples of what human civilization can achieve when knowledge, purpose, and engineering excellence combine. The secrets of Giza aren't just about ancient construction techniques or lost technologies. They're about the resilience of human intelligence and the possibility of preserving knowledge across any catastrophe. The builders who survived the Younger Dryas and left these monuments understood something profound about permanence and purpose. They knew how to create works that would endure when everything else failed. Their legacy challenges us to think beyond the immediate concerns of our own era and consider what we might create that could survive comparable catastrophes. The Great Pyramid and its companions have stood for over 12,000 years, preserving evidence of capabilities we're still struggling to understand. They prove that with sufficient knowledge and determination, human beings can create monuments that truly are eternal. But the story of Giza is far from over. The monuments continue to yield new secrets as investigation techniques improve and our understanding of ancient capabilities evolves. Each new discovery challenges conventional timelines and reveals additional evidence of the sophisticated civilization that once flourished on the Giza Plateau. The geological evidence speaks clearly for those willing to listen. The Sphinx bears the scars of rainfall that hasn't touched the plateau in over 10,000 years. The astronomical alignments point to stellar configurations from deep time, when the night sky looked completely different from today. The precision of construction and the sophistication of engineering demonstrate capabilities that challenge our understanding of ancient technological development. These monuments are more than impressive ancient constructions. They're witnesses to a lost chapter of human history, evidence of a civilization that achieved remarkable technological sophistication, only to see their world end in catastrophe. They preserved their greatest achievements in stone, creating monuments so durable and precisely engineered that they continue to challenge our understanding thousands of years later. The secrets of Giza remain largely unread. Hidden chambers wait beneath the plateau, sealed since construction and never officially explored. The true purpose of the monuments remains mysterious, their technological capabilities only partially understood. But the evidence already revealed challenges everything we thought we knew about human history and the development of advanced civilization. We stand at the threshold of discoveries that could revolutionize our understanding of the past and transform our perception of human potential. The stones are waiting to tell their complete story, preserving secrets that could unlock mysteries that have puzzled humanity for millennia. The water-carved walls of the Sphinx enclosure continue to whisper their ancient testimony, speaking of rains that fell when the world was young and green. The precisely cut stones of the pyramids maintain their impossible tolerances, preserving evidence of technologies that shouldn't have existed. The astronomical alignments point steadily toward moments in deep time when unknown builders looked up at alien constellations and decided to freeze those stellar patterns in stone. Each piece of evidence builds upon the others, creating a picture so far removed from conventional archaeological timelines that it seems like science fiction. Yet the proof is carved into bedrock that cannot lie, encoded in stellar positions that follow mathematical laws, preserved in construction techniques that demonstrate capabilities we're still struggling to match. So here we are, standing at the edge of a revelation that could rewrite human history. The water-worn walls of the Sphinx enclosure whisper their ancient testimony about rains that fell when the world was green. The impossible precision of the pyramid stones speaks of technologies that shouldn't have existed. The stellar alignments point to moments in deep time when unknown builders gazed up at alien constellations and decided to freeze those patterns in stone forever. Every piece of evidence we've examined tonight builds the same impossible picture. Monuments that witness the end of the Ice Age, construction techniques that rival modern capabilities, astronomical knowledge that spans thousands of years, engineering solutions that still baffle contemporary architects, all of it pointing to the same inescapable conclusion. The Giza complex is far older than we've been taught to believe. These aren't the products of Bronze Age pharaohs working with primitive tools. They're the achievements of a sophisticated civilization that flourished before the Younger Dryas catastrophe reshaped our planet. A civilization advanced enough to survive global catastrophe by encoding their greatest knowledge in monuments built to last forever. The geological clock can't be reset by academic consensus. The stars don't lie to support conventional timelines. The precision carved into every stone block doesn't care about archaeological comfort zones. The evidence speaks for itself, preserved in bedrock and starlight, waiting for anyone brave enough to listen to what the stones are actually saying. The monuments of Giza continue to guard their secrets, patient witnesses to a lost chapter of human achievement. They've waited over 12,000 years to tell their complete story. The question isn't whether more revelations await discovery. The question is whether we're ready to accept what those revelations might tell us about who we really are and where we truly came from. If this journey into hidden history has opened your eyes to possibilities you never considered, then support us with a like and subscribe if you're new to the channel. And let me know in the comments what mysteries you'd like us to investigate next. Until next time, sweet dreams and keep questioning. Good night.